A servo is a special kind of motor that's used in a lot of machines. The cool thing about a servo motor is that you can tell it to rotate to a certain angle and then just lock in there. It's used by hobbyists who fly remote control airplanes to raise and lower elevator flaps on airplanes, and it's also used by robotics hobbyists to control their robots. So we're going to control this servo motor using a potentiometer, and that will be the next exercise. So let's start this one with a completely clean solderless breadboard, take all the wires out of everything, so we're just going to start over from scratch. First of all, we will go ahead and plug the potentiometer in, and let's put it into row J, 1, 2, and 5. And we will go ahead then and attach a blue jumper wire. It doesn't really matter what color, but I like to just kind of match them with the function. So we'll put that in row 1, a jumper wire in row 1, and attach the other end to ground. And then we'll take another jumper wire, I'll use red this time, and we'll put this in row number 5. We'll go ahead and attach it to the red rail here. And then what we can do is we'll just power up this entire rail by putting another jumper along the red rail and going over to 5 volts on the Arduino and getting another jumper cable, plugging it into the blue rail on the breadboard, and then plugging this one into one of the ground pins. So now this whole rail is supplying power. So whenever we plug components, we can just plug it into the rail. And that will be a nice way to do it. Okay, so now we have one more pin here on the potentiometer that hasn't been connected. That's pin number 3. So let's insert a jumper somewhere in row 3, and then we will go over to analog input pin 0. That's A0. So what this is doing is it's measuring an analog signal from the potentiometer. That's its input. Okay, so now we have the servo motor, and it also has 3 pins. And you can see that they are colored black, red, and yellow. The black one is for ground, the red one is for the positive voltage, and then the yellow one sends the pulse width signal to the, or it actually receives a pulse width signal that causes it to rotate to a certain angle. Depending on how you modulate or change that pulse width, you can control the angle of the servo. That's called pulse width modulation. So let's go ahead and plug this into our solderless breadboard, and we will put it so that let's put it into row H into 10, 11, and 12, so that black is in 10, red's in 11, and the yellow one is in 12. Okay, so as you might guess, what we want to do is connect the black to ground and the red to positive voltage. So I need to get a couple of jumper wires to do that. I have a large bag of jumper cables here. We'll take a red one, and we will insert it in somewhere in row 10, and then we can just put it anywhere along the red rail, because we're going to get power to it that way, because we've electrified those 2 rows. And then let's do, oh wait, I had it in the wrong one, I'm sorry. It's row 11 is plus 5 volts. And that's why it's kind of good to have the colors matching, because colors matching between your component wires and your jumper wires, because it can help prevent making mistakes in wiring. So then I'm going to use a black jumper wire, and I'll put that in row 10, and then I'm going to put it into the blue rail here. And so now we have this activated. We have the only one that's not connected so far is the yellow wire, the signal wire. So let me get a yellow jumper wire, insert it somewhere in along row number 12, and then I'm going to put it into digital pin number 9. And if you look closely at this board, you'll see a little tilde symbol in front of the 9, and there's a code on the card that's printed. The tilde means PWM, that stands for pulse width modulation. This pin is capable of sending out little bursts or pulses of electricity, which is exactly what we want to control the servo. So now we have everything wired up. All we need to do is load up the example program on the computer and upload it to the circuit, and then we can control the servo. So let's do that now. What I want to do is go to Examples, and then go down to Servo, down near the bottom, and pick Knob. So I select Knob, and then I just click the Upload button, wait for it to compile the sketch and upload it. Okay, and so now what happens is if I turn this servo knob here, you can see that the arm on the servo changes when I turn the potentiometer knob. So you have kind of a direct control. You can see here how you can control that. And you could think there's all sorts of fun things you could do with this kind of a project already. You could attach a hand to it so you could wave to someone from a distance if you had a wire long enough. And so this is kind of a form of remote control with a servo. It's really fun to do. And that's it. So we've explored a few different output things. There's one other that we haven't tried yet, and that's sound. And so that will be the next experiment, is doing a way to manipulate sound by changing the intensity of light. That'll be in the next video.